Hello students, in this video we'll discuss a problem about an invariant quantity for an equilateral triangle. Let's suppose T is an equilateral triangle. For any point P, either on the triangle or inside the triangle, let D1, D2, and D3 be the distances to the sides of the triangle. Prove that D1 plus D2 plus D3 is constant, i.e. it does not depend on the point P. Okay, so let's draw the picture. So here's our triangle, our equilateral triangle. Equilateral triangle. So every side length over here is S, like so. And so let's recall what the area of this triangle is. The area of T is just the square root of 3 over 4 times S squared, okay? Great. Now let's be given a point in the triangle. So I give you any point either in or on the triangle. So let's give this point over here. I'll take this point for example. There's my point P. And then this distance over here will be D1. Then this distance over here will be D2, and this distance over here will be D3. And the key feature over here is that when I draw these lines from the point P, that's my point P over here, from those point P, from P to each of these side lengths, so if I call this triangle over here, if I say this is A, this is B, and this is C, and then this point over here is, let's call it point D, let's call this point over here E, and this point over here F. Right? Then what do we know? We know that from P to D, PD is perpendicular to AB. P to E is perpendicular to CB. And P to F is perpendicular to AC. Okay? Those are where the distances are. Now, that's what the area of the triangle is. Now, what can I do to prove this? What I'm going to do is the following. I'm going to form a new triangle. I'm going to look at these three triangles over here. So I'm going to take P and connect it to B and connect it to C and connect P to A, right? So now the area of T is also equal to the area of these three triangles. It's equal to the area of the triangle what? CPA plus the area of the triangle what? CPB plus the area of the triangle what? Plus the area of the triangle, the last one I have is BAP. Okay, and let's find those areas over here. So what's the area of CPA? The area of CPA is the length of the base. The length of the base is S. This is an equilateral triangle times D2. So it's going to be 1/2 D2 times S. Plus the area of CPB over here, that's going to be 1/2 D1 times S, plus the area of BAP is going to be 1/2 S times D3, 1/2 S times D3. Okay, so equating these two expressions, what do we have? If we equate these two expressions, we see over here on the right-hand side, this is really just 1/2 S D1 plus D2 plus D3. So since 1/2 S D1 plus D2 plus D3 is equal to this quantity over here, what we can conclude is the following. We can conclude, therefore, that D1 plus D2 plus D3 is equal to what? Is equal to, well, I'm going to cancel one of the S's and multiply by 2, so it's going to be the square root of 3 over 2 times what? Times a single S. And therefore, the sum, D1 plus D2 plus D3, does not only depends on S, the side length of the equilateral triangle. And just as a remark, this property does not hold for acute triangles, so note This is not true for acute triangles. Okay, and that's easy to see, right? Because what we can do is this. We draw an acute triangle like this. Okay. And I pick a point actually on the triangle over here. So I pick a point P over here, right? Then if that's my point, the distance from these two sides, the D2 and the D3, the distance, well, I'll get one of the areas. That would be one of my, the only distance that will survive over here is that long distance D1. So that would be a D1. And of course, what would the area of the triangle be? The area of the triangle would be, let's call that length over there X, and this length over here Y. Well, clearly X is smaller than Y, right? So in this configuration, X is smaller than Y. And then what can we say about the area of this triangle? Well, the area of this triangle would be what? If this was my D1 or my DX, my D1 over here, right? And D2 and D3 would be 0, so I'd have a D1, and then a X, and then a 1/2 would be the area. And then similarly, if my Y was over here, a different point over here in my vertex, then that would be my D1 over there, and that's going to clearly give me a different result over here, right? So if I go from here to here rather, or to Y, right, then that's clearly different than the D2. Y 1/2 would also be equal to A, right? But if the D1 plus D2 plus D3 was constant, then this expression would be equal to this expression, and that would force X to equal Y, which is not the case. So in other words, this result is only true for equilateral triangles. Thank you very much.